In this lesson, you will solve problems involving exponential growth and solve problems involving exponential decay. So these are going to be real-world problems that are those exponential growth and exponential decay functions that we talked about last week. So the first exponential growth function, the initial amount c, right here, that's the number in front, increases by the same percent over a given time. And I'll have this in your notes as well, but the r is going to be your rate, and that's going to be your percent as a decimal. And then t obviously stands for time, and so your time is going to be your power. And then the c, as it says in the definition there, is your initial amount. So it's going to be initial amount that you're going to increase. So the real world situation is the prize for a radio station contest begins with a $100 gift card. Once a day a name is announced, the person has 15 minutes to call, or the prize increases by 2.5% for the next day. So what we need to identify are our C, our R, and our T. If we can identify those, then it's just a plug and chug situation. So in this case, we have our initial amount, which is our $100. Our R percentage rate is 2.5%, and what I'm going to do is I'm going to write the decimal form here. So it's going to be 0.025. Then that way all I have to do is just plug that in. I don't have to worry about converting it later. And then we have our time, t. And in this case, we don't need to really worry about what t is going to be, because we're just going to write the equation. And when you write the equation, you can leave your time as time. So we are going to just plug these values in. Y equals initial amount, 100, 1 plus 0.025 to the power of t. Now we can combine this, and I would recommend that you do combine just so it's a little more simplified. So the best equation would look like this. 1 plus 0.025 is 1.025. So this is what you would write for your equation. Now, how much would the gift card be worth if no one wins after 10 days? So we're going to use our t as 10 here. So we will type in 100, 1.025 to the power of 10. So on your calculators, you will definitely need a calculator for this lesson. You're going to start order of operations to do the power first. We have to do exponent under power first. So we do 1.025 to the power of 10, and then you're going to multiply that by 100 times 100, and you get, and this is going to be in money, so you can go to the nearest cent here. This is $128.01. Okay, so questions on this, make sure you let me know. Try the example of an exponential growth in your notes. Now we're going to move on to compound interest. It is a new formula. It's still an exponential growth, but in compound interest, we're going to apply interest more than one time a year, and so we have to add that to the equation. A is going to be the amount of the investment, and that's going to be the total amount of how much you have after the interest is applied. P is the principal. The principal is the term for how much you're investing. The R is your interest rate, just like last time. N is going to be the number of times it's compounded. So let's talk about that. What you could see is an annual interest, and that would be one time a year. So N would be 1. A semi-annual is going to be twice a year, or every 6 months, and so we call that 2. N is 2. It could be compounded quarterly, which means that's going to happen 4 times a year, so the N is 4. Or you can have a monthly compounded, and that's going to be 12. Just some examples here. Most savings accounts are quarterly, so they'll apply interest, every 3 months. Most credit cards are monthly, so you're applied interest every month. So these are real-world situations of where you're going to have exponential growth, money invested, or money that is in a credit card situation, money that you've purchased, that is going to grow and accrue interest over time. So these are going to be your values for N, depending on the situation. I will make sure and identify all of these in the notes for you so you know exactly what each letter stands for. Tate's parents invested $14,000 at 6% per year, compounded monthly. How much money would there be in his account after 10 years? So our A is going to be our total amount for Tate. P in this formula is the principal, or how much is invested, so we're going to put 14,000. 1 plus 6%, so we have 0.06. Our N, this is compounded monthly, so N is 12, to the power of 12 times 10, because our T is 10. I did not identify all of the parts here, so let me do that for those of you that are struggling here. The P is 14,000, the R as a decimal is 0.06, the N, because it's compounded monthly, is 12, and the T for time is 10 years. So these values are what I plugged into that formula. Now, to finally solve this, let's do division first, because we have to follow order of operations here. So 0.006 divided by 12 is 0.005, and I'm going to add 0.005 to 1. 12 times 10 is 120, and I have 14,000 still out front. So we're going to take 1.005 to the power of 120, and then I'm going to multiply that times 14,000, and we get an annual, or our total here, $25,471.55. Remember, round to the nearest cent because it's money. So this is how much money Tate would have after 10 years, after not doing anything to it. It's just getting interest monthly. So this is the kind of savings account you would want. Now, these don't exist, just so you know. They're only quarterly, okay? All right, try the example of a compound interest in your notes. Now we're going to move on to exponential decay. You'll notice here the equation is very similar to the exponential growth, but it's a minus instead of a plus. That's the only difference. Y is going to be your final amount, C is your initial amount, R is the percent rate of decay, and T is time. A fully inflated child's raft for a pool is losing 6.6% of its air every day. The raft originally contained 4,500 cubic inches of air. So our C amount is our 4,500, that's our initial amount. Our R is 0.066 because it was 6.6%. And we're not going to worry about our time here because we're just supposed to write an equation first, so we're going to leave T as T. So this is Y equals 4,500, 1 minus 0.066 to the power of T. Now we do have to simplify this, 0.066, so this would be 4,500.934 to the power of T, Y equals. So this is a very good looking equation right here. Now estimate the amount of air in the raft after 7 days. So we're going to make our T 7. So I just use this same formula and change that T value here to 7. So we are going to have to do 0.934 to the power of 7, and then multiply by 4,500. Now this is not money, this is how much air is in the raft, so let's just go to the nearest whole here. So Y is equal to 2,790 cubic inches of air. Go ahead and try the exponential decay in your notes. The last thing we're going to talk about is depreciation. Depreciation is when you have something in value and over time it loses the amount of value. You see this in cars, this situation's with a tractor, you see it in homes. Depreciation happens as time goes on, it's not worth as much value. So it is an exponential decay. The exact same formula as exponential decay, all of our letters mean the same things. So his tractor that he bought for $50,000 is going to be our C value. If the tractor depreciates 10% per year, then our rate is going to be 0.1. And then if we want to know the value of the tractor in 7 years, our T is 7. As we plug our values in here, we have Y equals 50,000, 1 minus 0.1 to the power of 7. We do need to simplify inside here. 1 minus 0.1 would be 0.9. So we have 50,000 times 0.9 to the power of 7. Go ahead and do that now, 0.9 to the power of 7, and then we multiply times 50,000. Now this is going to be in money because this is how much money the tractor is worth. So we have $23,914.85. This would be the value of the tractor 7 years after it's purchased. Go ahead and try the depreciation example in your notes.